Hey everyone, physics adventurers! Welcome to the Room of L, your intellectual adventure and guide for physics learning. You've all heard of special relativity, right? Time stretches and shrinks. Space contracts. Sounds like pure fantasy, doesn't it? Super exciting! But the moment you try to memorize the equations and calculate, it suddenly transforms into a tough boss fight, right? Whose time is this delta t? Who measured this length L? Your brain feels like it's hit a bug. Galileo once said, "The great book of nature is written in the language of mathematics." But guess what? You don't need to fight complex math right from the start. Inside the physics engine of our universe, there is a much more intuitive and beautiful map that lets us hack the world. That's the wisdom scroll you'll unlock today. Are you ready, team? Let's jump into this quest to hack the laws of physics. Here is the destination for today's quest. Here are the 3 treasures, the 3 essential skills you will gain today. Treasure 1. Master the basic rules of the space-time diagram to capture time and space at a single glance. Treasure 2. The hack to accurately read the time and position of an event by switching axes for each observer. Treasure 3. The skill to take events written in words and plot them on your map with your own hands. In this quest, we won't dive into the deeper mystery of why these axes become slanted. No heavy equations either. First, let's max out your level by perfecting how to read and draw this map. Once you master this map, you'll be able to hack those tough relativity bosses in the next video in one single hit. Take a look at the screen. This is the map we are going to conquer today, the space-time diagram. Space and time, so that means an xt graph, right? Wait, looking at the screen, didn't you just think for a second, isn't this totally different from the regular xt graphs we've been using? Pause the video right here and examine the graph on the screen carefully. What differences? What strange features can you spot? Well, did you find the clues? That's right, this is an evolved form of the xt graph, but there are 3 crucial differences. First, 2 sets of graph axes are overlaid on top of each other. Second, the red set of axes is slanted. Third, the vertical axis isn't just t for time, it says ct. Looks pretty mysterious, right? But don't worry, we'll hack through them one by one. First, let's start with the ultra-important reason. Why are there 2 sets of axes, and why is one set slanted? This is the core origin of the name Special Relativity. The foundational rule of this theory is, how time and space look depends on who is observing. It's relative. So, if we have 2 observers who see things differently, why not just overlap 2 sets of graph axes? The slanted axes represent the shift in how things look due to special relativity. These 2 sets of axes in front of you represent our universe. How do we read them? That's treasure 2, so hold on just a moment. Finally, let's look at the third mechanism, the vertical axis ct. Do you know why we multiply time t by c, the speed of light? Speed times time equals distance. That's it! By multiplying time by c, we align the vertical axis to have the exact same unit of distance as the horizontal axis. It's a special specification of the universe's physics engine to put time and space on equal footing on our map. Have you ever heard that time and space mix together in relativity? Multiplying the coordinate axis by c puts space-time on an equal footing. This is also super useful for graph representation. I'll show you how awesome this is later when we actually plot it, so look forward to that. Alright, that wraps up the basic structure of the space-time diagram. Now, let's set up our world building and jump right into hacking Treasure 2 and Treasure 3. Now, let's set up the world for today's scenario. Imagine a high-speed rocket passing right next to an observer on Earth in deep space. moving at a constant speed. The exact moment they pass each other is defined as time 0 for both Earth and the rocket. The black perpendicular axes are for the Earth observer. We call this the S frame, with the X and CT axes. The red slanted axes are for the rocket observer. We call this the S prime frame, with the X prime and CT prime axes. And let's add one more element to our world building. Floating quietly 5 light-years away from Earth, there is another star. It's time to unlock the identity of these super important points. In this physics map, every single point, like the point A on the graph, represents an event. An event is simply a space-time log, a record of when and where something happened. For example, the Earth and the rocket passed each other. The rocket fired a single laser beam. All of these are plotted as individual points on our map. Here comes the most mind-blowing part. The fact that an explosion happened or a laser was fired, the physical log itself, the point, never changes, no matter who is looking at it, right? Whether you are on Earth or in the rocket, the fact that the star exploded is an absolute, unchanging truth. However, when reading the numerical values for the time and location of that point, depending on whether you read it through Earth's glasses using the black axes or the rocket's glasses using the red axes, the coordinate values will shift dramatically. When using the black axes, which intersect at right angles, you just read them as usual. But when reading coordinates from the slanted red axes, you don't drop a perpendicular line. Instead, draw a line parallel to the other red axis until it hits the target axis. That is the absolute golden rule of this map hack. Even if the axes are slanted, as long as you know this rule, you can perfectly read how each observer sees the world. This is so crucial, so let me repeat it. The fact of the point, the event itself, is one single reality. But depending on whether you wear the black glasses or the red glasses, that is, which observer's perspective you take, the values for time and position change relatively. Always be aware of which glasses you're wearing, the black axes or the red axes. Just doing this will eliminate almost all brain bugs. Understanding the concept alone won't earn you XP. Now it's time to take action and hack our second treasure in real time. Let the practice quest begin. First, let's start with a warm-up. Let's read the coordinates of point P1 using the orthogonal axes of the Earth observer, our black axes. Take a look at P1 on the map. The black axes are regular perpendicular coordinates, so this is super straightforward. From P1, draw a vertical line straight down to read the x-axis, and we get 0. Reading the CT axis, and we get 4. So for the Earth observer, the coordinates of P1 are x equals 0 and CT equals 4. This means an event that happened right at Earth's location, x equals 0, at the timing when CT equals 4. Orthogonal coordinate hack complete. Now for the next level, the hack for reading oblique coordinates. Let's read that same point P1, but this time through the glasses of the rocket observer, our red slanted axes. Remember, do not drop perpendicular lines at right angles. The golden rule is draw lines parallel to the observer's axes. From P1, extend a line parallel to the red space axis, the x prime axis, until it hits the red time axis, the CT prime axis. Read the mark where it lands. The position is roughly -3, and the time is roughly 5. Since the rocket passed Earth at t equals 0, an event happening on Earth appears behind the rocket, at a negative position. We can calculate the exact numbers using Lorentz transformation equations later, But for now, if you can visually read this from the graph, you get a full score. By drawing parallel lines correctly, you can read the other observer's spacetime coordinates perfectly, even on slanted axes. Even so, time is especially mind-blowing, isn't it? Through Earth's glasses, CT equals 4, but through the rocket's glasses, CT prime equals 5. The physics engine of special relativity is ridiculously cool, right? All right, companions, this is where the most critical training begins. The most important thing in physics isn't just staring at formulas or theory. It's moving your own hands and brain, practicing properly, and absorbing it into your muscle memory. From here on out, we're going to dash through these quests at a breakneck pace. Let's get every question right and farm tons of XP. Are you ready, team? Quest start. First up, Quest 1 and Quest 2. Look at the map. We have 2 points, point Q1 and point Q2. Using only Earth's glasses, the black axes, let's read the coordinates for these 2 points. Take a moment to figure them out. 3, 2, 1. Orthogonal black axes, it's super simple. Point Q1 has position x equals 5 and time c, t equals 1. Point Q2 has position x equals 5 and time ct equals 5. Look closely at the screen. Let's draw a vertical line straight through x equals 5, passing through both point Q1 and point Q2. What do you see? That's right. Even as time passes, ct equals 0, 1, 2, all the way to 5, this object stays continuously at position x equals 5. As time flows forward, how an object moves through space leaves a track. When you connect those footprints in spacetime into a single, continuous line, the physics world calls it Worldline. This vertical line is the world line of that star floating stationary 5 light-years away from Earth. Can you feel how individual event points connect to form the footprints of spacetime? Moving on to Quest 3. On the red axis, the rocket's frame of reference, there is a point Q3. Through the rocket's glasses, its position reads x prime equals 0. Let's read this exact point using both sets of glasses, red and black. Ready? Read the coordinates from the graph. 3, 2, 1. Through the rocket's glasses, the red axis, it lies directly on the red time axis. So position x prime equals 0 and time c t prime equals 4. But what happens when we read it through Earth's glasses, the black axes? From point Q3, drop vertical and horizontal lines straight to the black axes. Both position x and time ct read as positive values. So from the graph, x is about 3 and ct is approximately 5. They're actually 3 and 5, but don't worry about the exact values. We'll get those later using the Lorentz transformation. For the rocket observer, it's an event happening right inside their stationary rocket at x prime equals 0. But for the Earth observer, it looks like an event happening far away. Absolutely perfect. Let's keep up this great tempo. Quest 4. This time, point Q4 is higher on the same red time axis. Through the rocket's glasses, x prime equals 0 and c t prime equals 6. Just like before, extend lines parallel to the black axes. 3, 2, 1. From the graph, x is about 4.5 and ct is about 7.5. Every point along this red time axis has x prime equals 0. So, that's right. This red time axis, the ct prime axis itself, is the world line of the rocket traveling through space. Isn't it mind-blowing that the axis itself is the actual trajectory, the world line, of the object? Now, for the final question of this set, Quest 5. Let's see if you can spot this in a split second. Which line on this map is the world line of the Earth observer themselves? Here's your hint. An observer stationary on Earth through Earth's glasses stays at position x equals 0 no matter how much time passes, right? So 3, 2, 1. The correct answer is the black time axis, the CT axis itself. The world line of stationary Earth is a straight, vertical black axis, while the world line of the rocket moving at constant velocity is a slanted red axis. Outstanding! You cleared all 5 quests and completely mastered both map reading skills and the concept of world lines. Your player skill has leveled up immensely. All right, welcome to the final stage. Time to activate Treasure 3, the skill to plot on the map with your own hands. First, Quest 6. Your mission is to plot an event point. An Earth observer at x = 0 fires a single laser beam toward the star at the exact moment their clock reads CT = 2. Let's plot this laser firing event point on our map. Ready? Place your dot. 3, 2, 1. Since the problem says Earth observer, let's use the black axes. Think through the glasses of the Earth observer. Position is Earth, so x = 0. Time is the exact moment of firing, so CT = 2. That's right, it's the point 0, 2. Let's place an event dot right here. Moving straight into Quest 7. Now your mission is to draw a world line. Let's put that drawing training into practice with your own hands. Draw the world line of light on the map for the laser beam emitted from the Earth until it reaches the star 5 light years away. Are you wondering, at what angle should I draw the world line of light? Remember, the vertical axis isn't just time, it's CT, speed of light, c times time, t. Light travels 1 light year in 1 year. This means when a time of CT = 5 passes, which corresponds to 5 light years of time, light travels exactly 5 light years in distance. Ready to draw? Take your best shot. 3, 2, 1. So draw a straight line at a 45-degree angle starting from 0, 2 we just plotted. Did you get it? Yes! Fantastic! By multiplying time by the speed of light, c, we put time and space on equal footing. Thanks to this, in the physics engine of a space-time diagram, an absolute rule is forged. The world line of light always forms a plus-minus 45-degree line for any observer. 45 degrees going forward in space, and minus 45 degrees going backward. Super convenient, right? And just like that, you've mastered the basics of the space-time map. Plot the events, connect the dots, draw the world lines, and with that, Treasure 3 is officially yours. Congratulations, player! And there we have it! You now know how to read and draw a space-time diagram. But here's where things get really interesting. With just this map, we can answer questions like, when does a flash of light reach the rocket from Earth's point of view, and from the rocket's point of view? The light reaches the rocket at this point. By reading the axes, we can find the time for the Earth observer here, and the time for the rocket observer here. Or, when does that same light reach the distant star? This is the moment when it reaches the star, and we can simply read the time from the diagram. Like this, we can figure all of this out just by reading the diagram, without doing any calculations. How was that? Once you learn how to plot on the map with your own hands, your view suddenly clears up, right? You got 3 treasures today. Marking dots and drawing lines on a map might seem simple at first glance, but this foundational skill, this XP, will become your ultimate weapon. In our next video, we'll use the space-time diagram we unlocked today to take down the 3 big bosses of special relativity: time dilation, length contraction, and relativity of simultaneity. With this map, you'll see exactly why they happen at a glance. So get ready, player! The next quest awaits!
If you enjoyed today's walkthrough and earned some sweet XP, hit that subscribe button and like the video to join our Adventurer Guild. Drop a comment below if you have any questions or if there is a specific problem you want me to hack next. See you in the next quest. See ya and keep exploring.